All right, I'm live with 52 weeks of Rust, and I'm going to be covering. I think last time I was stuck on maybe some things with looping, I believe, and also was going to cover some topics around ownership today. So I'll get right to it and share my screen here. Let's go ahead and do that. Language. Here we go. All right, so we got the language guide up here, which was one of my sources. And I'm going to go over to this repo, 52 Weeks of Rust, GIBJJ, and go to one of these. It looks like this is a good one. And we can make this a little bit bigger. There we go. All right, so in terms of Rust, if I recall, I was inside of here, and I believe I was looping. And one of the things I was trying to figure out was why my loop was not working, if I remember correctly. Here we go. So it's all coming back to me. So we'll go and create a new terminal. And I believe last time I had an issue with learning to convert something to an iterator. So that could be a good thing for me to dive into. So I'm gonna cd into that repo or into the project structure, and I think I can just say cargo run, right? There you go, cargo run, and then let's take a look at what I was trying to do. I guess I've got that working, but if I wanted to do something a little bit trickier, is it in here? Let's see here, main. Yeah, this is it. Okay, so I'll go up one level. So we'll go up here and we'll go into episode 4. And I'll do cargo run and it should not work. There we go. So we have a problem, and the warning is, first of all, I have an unused import, and it says thread RNG is not an iterator. The trait iterator is not implemented. So it looks like my idea of randomly grabbing variables or grabbing things out of a list is not working because I don't understand how to do it. And I guess I could use my friend Google. We'll say something like random choices Rust, see what happens. There you go. Implementation. Yeah, so this is classic in Python. You can do this with a custom seed. Okay, so let's see here. External crate random choice, use. Okay, well, why reinvent the wheel? Let's try this out. So I'm going to just essentially replace this. And we see extern crate random choice. And what happens if I just run this? We'll say cargo run and let cannot compile due to previous error. So let mutable sample. So why is let not working here? For mute samples. Let's double check here. And what is this? I guess this is so random choice is implementation of the universal sampling algorithm, blazingly fast, low memory usage. But why is this causing an issue? Extern crate. I also don't know what that does. So let's take a look at this. It declares a dependency on an external crate. The crate is then bound into the scope. So maybe we have to build this first. Let's see here. So if I say cargo build, what happens? Cargo build, same thing. Expected item found keyword let, and this is on line 4. Let samples. Could not compile. Let's see what this means. I don't know my debugging yet with Rust. Okay, here we go. I have a code dump where I put examples in case I forget it. I keep getting error, expected item found let. Could it be my code isn't structured properly? Blah, blah, blah. Your fundamental issue is let can only be, can only be used in a function. So wrapping the code in a main and also fixing the style. Oh, okay. Well, let's try this out. That could be the issue. If we say let, so it has to be used in a main. Okay, well, thank you, Stack Overflow. Maybe I'll even add this as the docs. It's out of here. Thanks, SO. Okay, so that probably is the issue. Is I need to make a main function. So we'll go ahead and just copy this stuff and just swap it out. So we'll just take this stuff out of there. And actually, probably just can do this. And then let's do this. Close this. There we go. This looks like this could work actually. And now what happens if I say cargo build? Could not find crate for random choice. So this is maybe getting us closer here. If I go to cargo, let's change this to the I'm just guessing here, but let's change it to random choice. Now, I'm still learning about how to know the version numbers here. I guess I'll look at the Rust crates and just look at the docs. And there we go, random choice. So there's a 032. Okay, let's pick that one. And I'll go back to the cargo file. And we'll do this. There we go. And then let's just double check. Syntax is it looks like it's random underscore choice. Let's just add this in there. This is the crate. Okay. And we can link to it. And I think this is gonna, I'm hopeful this will work. Okay, random choice. Now what happens if I do build? Excellent. We've got an external dependency loaded, which is promising. Although, boy, talk about a long time to install. Okay. And the build is only got a warning, which is nice. Unused samples. So let's go back here. Samples. I wonder why it says it's unused. It certainly looks used right here, but okay. But it compiles. So now let's say cargo run. And whoa, there we go. So let's see here. It says hi. This is a test. So the samples are generated are here. Here's the weights. We do 100 choices and we see a random choice. Pick from these samples, which are right here. And I'm assuming this is weighting each choice as they're chosen, which is kind of interesting. And then the number of choices here is 100. So it's going to pick 100. So what happens if I just want to pick like 2? Let's try that. And we got 2. We got 2 choices. Okay. And well, that's how you do random. That's how you do random numbers. So that's kind of cool. Or random choices. And this is, I don't want all this stuff inside of here. This would be nice to figure out how to not check it in. Let's see if we can figure that out as well. How to not check in REST artifacts. Okay. Oh, cargo sweep. Avoid build cache float. Huh. Cargo sweep. That's interesting. How to avoid checking in REST artifacts. Okay. You can cache the targets. I need like I think I'm just not getting my get ignore to work properly. I don't think I have one inside of here. Yeah, I don't have one. So that's probably the issue. Because if I CP up a level and I go to get ignore here, what happens if I say get status now? Here we go. This looks a little more reasonable. There's still some weird stuff. I guess that makes sense. Like this, why is that checking that in? But sure, let's do this. So we'll take it, add star, git commit, adding random choices, loop. So that's pretty cool. We got some good stuff cooking here, and probably don't have time to do much on ownership other than just look at it a little bit. So let's look at it and we'll set it up for next week. So I'll put this into the README. So we did fix this. Yep. Say hooray, we fixed it. So we fixed it. Next up, we want to do, we're on ownership here. So episode 6, fixed random choices and started ownership. And we'll say episode 7, more ownership. I have a feeling this is an important concept just from my very little bit of going into the material. It's almost nothing. And we'll put a note here. There you go. Ownership. So what do we need to know? So ownership most unique feature, maybe it is because I read that. It enables Rust to make memory safety guarantees without needing garbage collection. So it's important to understand how it works. All right. So what is it? So it's a set of rules that governs how Rust manages memory. Some languages have garbage collection. Other languages, the programmer controls memory, which I hate. And I've written commercial programs where I had to do this and I just hated it. And then Rust uses a third approach, which is memory is managed through a system of ownership with a set of rules that the compiler checks. If the rules are violated, the program won't compile. None of these features will slow down your program. Oh, interesting. So yeah, it is a new concept. I've never heard of it. The good news is you'll get used to it. Okay, so languages don't require you to think about the stack and the heap, but in systems you do. They're important to use at runtime. The heap is less organized. Accessing data in the heap is slower than on the stack. When your code calls a function, the values passed in, etc., etc. Ownership rules. Okay, so each value in Rust has an owner. There can only be one owner at a time. Now that we passed, we won't use this. Make sure you're putting the examples on a main manual. Okay, so I guess this was a newbie mistake I was making, is that if you don't make a function, a lot of bad things happen. So every time they give us an example, we need to actually go through here and make examples that have the function. So here's an example. We have a string. This is not valid. The scope is now over, and S is no longer valid. So it remains valid until it goes out of scope. The string type, to illustrate the rules of ownership, we need a data type that's more complex. And I don't, okay. So we'll concentrate on strings. So here's a string. The double icon allows us to use the namespace from. This string can be mutated. What's the difference? Why can a string be mutated but literals can't? So it's memory. When the string type is mutable, growing piece of text, we need to allocate memory to it. The first is done by string from. So the memory is automatically returned once the variable that owns it goes out of scope. So here's a version. Okay, that's interesting. So we've got memory here, and then once the control flow passes that, then the memory is removed. When a variable goes out of scope, Rust calls a special function for us called drop. Drop is automatically called at a curly bracket. That's pretty cool. So ways variables and data move. So here's some variables. Here's a string. So that part seems reasonably intuitive. And so you'll get an error like this because Rust prevents you from using an invalidated reference when it goes out of scope. To ensure memory safety, after the let S2 is equal to S1, Rust considers S1 no longer valid. Ah, interesting. Wow. Okay. And you get an invalidated reference. Well, that's pretty cool. And the way the variables and data interact is through clone. And so we could go through here and we could clone some stuff. If you do want a deep copy, you can do clone, and then the other one still exists and the new one exists. The code using integers is also valid because X is still valid. It wasn't moved into Y. Integers have a known size and compile time, so copies are quick to make. There's no reason to want to prevent this. Okay, so that's good to know. So integers are slightly different. The mechanics of passing a function value to a function are similar to assigning a value to a variable. Passing a variable to a function will move or copy just as assignment does. Interesting stuff. So I guess I could play with this. I have a few minutes. Let's copy this. And I'll go back to my repo and let's just make another directory here. And go up a directory. Say cargo. Let's look at the history. I'm still learning the cargo commands, but history is a great way to find them out. So cargo new, there we go. So we'll say cargo new episode 5, ownership, and then we'll CP get ignore into that directory, which is something I've been forgetting to do. I'll change into it myself. Now, if we go to episode 5 and look at this file, we can just swap this stuff out and try to get this to run. So what does this do? So we have a function, comes into scope, takes ownership, moves into the function. So there's no longer valid here. Now, who take ownership? Some string. Oh, I see. So there's a function called take ownership. And then this comes back in. This comes into scope. X is equal to 5. We make a copy, and the copy will just print it out. Okay. It's an interesting example, but let's build it out. And then let's go ahead and say cargo run. All right, so I might understand ownership based on what I've read so far, but I'm going to keep going next week because there's a little bit more in here referencing borrowing the slice type. So interesting concept, very interesting. All right, I'm going to go ahead and check this in. So let's look at this, get status, and we see that the get ignore is working, which is nice. And let's say get add. Let's just go to the top actually. Now let's say get status. What do we got? Get add everything. Get add. This get ignore. Commit this. Episode 5. There you go. And it's in. Perfect. All right. Well, that was a pretty actually effective episode. Next week, we'll continue to do ownership. I will see everybody next week.